Good morning. Welcome to the 7th annual Yampa Basin Rendezvous, connecting the drops, linking weather, watersheds, and communities for a resilient water future. We're so glad to have you all here today. My name is Garrett McGurk. I am a hydrologist at the Center for Western Weather and Water Extremes. I'm a co-chair for this year's conference with Jenny Fritzen here.
And hi everyone, my name is Jenny Fritzen. I'm the Environmental Program Manager for Friends of the Yampa and a proud member of this year's steering committee for the Yampa Basin Rendezvous. We'd like to extend a thank you to Jeff Hall, a longtime Steamboat resident and local photographer. His beautiful photograph, A Photo Worth 1,000 Words, will be found throughout the conference materials today and tomorrow. It beautifully captures spring moisture, early growth, and agricultural heritage at the base of the beloved Elk Mountain, locally known as the Sleeping Giant.
New for YBR this year, we have a brand. This is pretty exciting for all of us on the steering committee. So, huge thanks to Caitlin Hollister at Stand Creative Studio for creating this brand for us. So this brand really speaks to the rich history of our relationship with water, working lands, and resilient natural history and cultural heritage. Come to our evening showcase tonight. You'll have an opportunity to get branded. I'll leave it at that.
At its heart, the Yampa Basin Rendezvous is a dialogue. It's a chance for us to learn together from experts and to share our ideas and experiences.
For 7 years, YBR has served as a platform to convene our community, scientists, students, ag producers, water managers, educators, water policy experts, and local water leaders.
And this work definitely wouldn't be possible without the many wonderful partnerships. I want to extend a welcome to all of our 2024 conference speakers and the organizations that they come from. They have all worked so hard, and we are so grateful to have each of you here today. Oh, and their detailed bios can be found on your table in the colored agenda, also with a description of their work.
We'd also like to take this opportunity to acknowledge the rest of our steering committee who is here today. Without their hard work, we wouldn't be here. So thanks to the vision, hard work, and dedication of the steering committee, we would like to thank you all for being here. If steering committee members could rise to be acknowledged.
All right, and one more thank you. We'd like to thank our event sponsors. Each of the steering committee members comes from one of these organizations who have just been so generous in their donation of staff time, resources, and financial support. I would also like to thank our community sponsors for the lodging, food, and event space that is making this conference a reality. Dusky Grouse Coffee, the Yampa White Green Basin Roundtable, Yampavian Lodge, Yampa Valley Brewing Company, Steamboat Ski and Resort Corporation, and the Boat House. Thank you so much.
We also, one more thank you here, to our CMC, IT, and facilities team. They are rock stars. You have them to thank for this amazing venue, this campus, and the opportunity to convene YBR here this year.
And while you are all here in Steamboat, it would be wonderful if you could take some time to visit the Tread of Pioneers Museum. For about another week, they have 2 Yampa River exhibits, Lens on the River, a photographic journey on the Yampa River with John Fielder, and the Yampa River from the Flat Tops to the Green River, which is both an exhibit that focuses on science and history of the Yampa River. The Tread of Pioneers Museum has graciously extended free admission to all YBR attendees. And kind of a final announcement before we really get started. If you are still looking for some summer learning, we need a few more registrants for a summer field course called Yampa River Ecology. This class starts on June 10th. It's a 2-week field course that's offered through a partnership between Friends of the Yampa, Colorado Mountain College, and Colorado State University. Participants get to spend 2 weeks on the Upper Yampa and Bear Rivers, walking and studying 31 miles, well, maybe not walking 31 miles, but experiencing a 31-mile stretch of river, collecting data, and that data collected by students in this course informs the ongoing Yampa River Scorecard project. So we do need a few more participants. If you're interested, please reach out to Luke Kemmis at Colorado Mountain College. Which brings me to our welcome speaker today, Carrie Besnett-Hauser. It's my pleasure to introduce her. Since 2013, Dr. Carrie Besnett-Hauser has served as president and CEO of Colorado Mountain College. She is the immediate past chair of the Colorado Parks and Wildlife Commission and a member of the Nature Conservancy of Colorado, Vail Valley Foundation, American Council on Education, and Chapman Foundation for Caring Communities Boards of Directors. She has held policy, research, and legislative staff roles, as well as positions with the Western Interstate Commission for Higher Education and the University of Arizona, her undergraduate alma mater. She earned her master's and PhD degrees from UCLA and completed the Advanced Management program at the Wharton School of Business. An avid outdoorswoman, Hauser has climbed to the Mount Everest Base Camp and has summited Mount Kilimanjaro, Mount Rainier, and Colorado's 58 highest peaks. Welcome, Carrie.
Awkward pause. Good morning, everyone. Oh, that was sort of tepid. Good morning, everyone. It is great to be here. This is a wonderful event, and it's fun when it becomes muscle memory. And we come back every year. I remember the first one, certainly, and the fact that we're all in a groove around this really important work is just terrific. So thank you, Jenny, for the great introduction. I'm Carrie Hauser, president of Colorado Mountain College, and it's my pleasure to welcome you to the Yampa Basin Rendezvous. And just 2 points of personal privilege. One is today is my wedding anniversary. So you all, those of you that know Jeff can say that I was honest about that, and I'm not with him today. And the second is that this is my final YBR as president of Colorado Mountain College. As many of you know, I announced that I'm stepping down from this role after almost 11 years. And it has been such an incredible journey. And this event and this campus and this valley and the history that is just exudes from this place are really, really special. So I'm not going to be very far. Look forward to chatting with folks on the breaks, and just want to say how special this is. So I'm thankful to Nathan and the steering committee and everybody who has included me from the very beginning of this since its inception. So thank you very much for that. So I want to thank the steering committee because we wouldn't be coming together today, obviously, without them across several states, including UC San Diego, obviously Colorado Mountain College, Friends of the Yampa, the Nature Conservancy. I just joined the Nature Conservancy Colorado Board. I'm literally attending my first meeting this weekend here in Steamboat. You got that, State of the Yampa, you got everything going on in the next 4 days, right, Kent? The Yampa Valley Sustainability Council, River Network, Yampatika, the Community Ag Alliance, and the Upper Yampa Water Conservation District. So thanks to all of them. And to our research and academic colleagues from Scripps Institution, the Center for Western Weather and Water Extremes, CW3E, the Center for Environmental Journalism, which is the University of Colorado at Boulder, the Colorado Climate Center at CSU, the Colorado Water Conservation Board, and the Colorado Department of Natural Resources. So thank you so much to so many collaborators. It's grown every year. People and organizations want to be part of something successful, so they clamor on, and it's great. Now you can be picky, right? Decide who doesn't get to be on the list of logos. And to all the various partners and sponsors, all of whom will continue to be acknowledged over the course of the next couple of days. So if you'll indulge me, and in line with the theme for the next couple of days, I'd like to connect a few drops. And that's from CMC's founding to this crucial conference and beyond. I used this recently in a TEDx talk, and we scrounged up this old diagram of CMC, which is kind of cool. So Colorado Mountain College, for those of you who are not super familiar with us, you may come to the campus, you may know about us a little bit, where we're kind of unique. We kind of like that. We're founded in 1965 by a group of people that sort of saw beyond themselves and created a brighter future for generations to come. And you'll see back then, much like today, there's no other college within a 60-mile radius of a CMC community, which is why we exist, and it's why we were created. One of our my former trustees, Ken Brenner, is in the room. Certainly worked closely with him for a number of years. And led by a young minister and head of the Glenwood Chamber of Commerce, David Delaplane, who's down in the lower right. The communities of Garfield, these are the counties of Garfield, Eagle, Summit, Lake, and Pitkin counties, originally all came together and voted to tax themselves. That's a pretty amazing thing, and it's happened since then, to create a taxing district to fund this college that was independent from the state. It's not a private institution. It's not a community college. It's not a big university. It's sort of something in between. Certainly, we are very much part of these communities, and just given our mix of programs, we are sort of a dual mission hybrid institution in that way. Local municipalities, as well as young ranching families, donated land to build our early college campuses. And in the early 1980s, anyone here? Do I date you? Who was here in the early 1980s? Okay. History repeated itself. And I love the fact that chambers of commerce, centers of business, said that we need to train people to fuel the economies of these mountain communities. So the original CMC was created and born out of the Glenwood Springs Chamber of Commerce and the Leadville sort of business community, and it happened again here in Steamboat Springs. And then, anyone know Bill Hill? Anybody remember Bill? A number of you in the room. He was then the head of the Steamboat Springs Chamber of Commerce, and once again, he saw an opportunity, and he quit his job to start what is now the Yampa Valley Community Foundation, with the sole purpose to prevent this very location that we are sitting in today from becoming ski condos. Can you imagine? It would be really nice views, but it would be ski condos. You see, back then, that two prior colleges that had served this region both failed. The original was Yampa Valley College, and it was founded by the incomparable Lucy Bogue. And if you don't know who Lucy Bogue is around the history of Steamboat Springs and this campus, go find a little book called Miracle on a Mountain and read that, because it's an incredible history about Lucy and what she did. It fell on hard times. It was bought by a for-profit, interestingly way back then, a for-profit international university out of San Diego, which also went bankrupt. Don't let a good crisis go to waste, right? Bill saw an opportunity to join CMC, and as you look around and as you experience this incredible place and the opportunities that CMC offers, this is what Bill and that legacy did for us. So these legendary pioneers acted on ideas that would benefit people they would never meet and communities they could never have dreamed would evolve the way they've dreamed. And precious river valleys that would come to rely on the creativity and the steadfast determination of the people who now live here and care about these places. Everyone in this room is the next generation of David Delaplane, Lucy Bogue, and Bill Hill. So I think it's quite remarkable what can happen when we all come together to protect something that is important, not only to us, but to future generations. We work very hard every day to honor their commitment and dedication and provide essential educational opportunities to our mountain communities. So today, that's the map. Little kernel of an idea, all that yellow is Colorado Mountain College. 11 campuses spread across 9 mountainous counties. We have 14 wilderness areas. Most of the big ski resorts, obviously, it's the size of Maryland. And we offer programs ranging from short-term certificates to associate degrees to bachelor's degrees directly connected to the workforce and the community needs. That's why we were founded, and it's why we still exist. And it's why we're still really relevant today. If you think about what's happening across higher education, just take a moment and think about that. Sorry for some of the biggies in the room. It's a challenging environment. And we know that our value proposition is that we are completely locally centered, and that's our job. So some of our programs range from Geographic Information Systems, GIS, for those of you who call it that, avalanche science to outdoor education, ecosystem science and sustainability studies. We're also, because we are locally funded through residential and property tax, our job is to return on the investment that our taxpayers make in us. Not one of the employees at CMC would be here and have a paycheck if that were not the case, and not one of our students would benefit from their education if that were not the model that we operate under. And that includes issues that impact us locally, including the environment and our watersheds. Love those pictures. So some of you have heard this story a little bit in past YBRs, but many years ago, I was asked to serve on the American Rivers Board of Directors. And this was fairly early in my presidency, and I thought, oh, Ken Brenner, one of the other board members, like, how do I make the case that serving on the National American Rivers Board is like aligned with Colorado Mountain College, right? So, I'm a sort of a self-confessed river rat. I worked in the Grand Canyon for a number of years on the Colorado. And so I needed to sort of make my case. So I asked a couple of work studies in my office if they would count the number of rivers that sort of run through this footprint, right? So they went to work and they came back and thought it was kind of a simple exercise, and they came back with like 8. I'm like, what? I knew that wasn't right. I mean, I sit in Glenwood Springs at the confluence of the Roaring Fork and the Colorado rivers, and I know that Chestnut River, right? The Flat Frying Pan dumps into that. The Crystal River dumps into that. So that's 4 right there. So probably not 8. So I said, would you please go back and try again? So they went back and did a better job, and this is what they found. So you can kind of see all the sort of rivers that flow through our footprint in some way or shape or form, obviously a couple of headwaters, but 9 major rivers, 16 secondary rivers, 21 major creeks, and 400 unique creeks and streams flow through our boundaries. So I think, Ken, I made my case, right? That the rivers and the CMC and Colorado Mountain College are definitely linked. And it was a fantastic opportunity to bring American Rivers into the CMC community and vice versa. So it's hard to believe that this notable convening began 7 years ago at CMC's Steamboat Springs campus with our now very close partners at UC San Diego, Scripps, looking for a conference venue. And our collaboration and partnership grew into what is now an annual conference that brings together people from across the state and beyond and benefits our rivers, watersheds, and communities on Colorado's western slope. So it is a sincere point of pride that our students and faculty have been involved since the inception of YBR. Each year we offer a course to align with the conference, and this year the course is, and I think it was mentioned earlier, Western Weather and Water. And CMC has 10 students participating with us today, and I think they were kibitzing right there when I first came in. So if you'd please stand for our students and recognize them. Please take note and get to know them a little bit later if you can. So several students in this year's course just completed onboarding for their summer positions with Colorado Parks and Wildlife and the U.S. Forest Service. Make a visit to our local Steamboat Lake State Park or our Medicine Bow Route National Forest Field Office, and you're likely to meet the 7 full-time employees and 5 seasonal employees that we have there. And over the years, student research has focused on snowpack, stream flow, soil moisture, and post-fire forest health. And we're also proud to celebrate that we have our very first student co-authored publication from the Yampa Basin Rendezvous Conference related work. It's pretty amazing, and that's not all. We have 2 students who are participating in internships funded by Scripps to conduct research in the Yampa and Roaring Fork Basins. In 2024, interns Fallon Santander and Chloe Denning began bring the number of students selected for the nationally competitive CW3E summer internship to 9. A couple of photos there. And the positive outcomes of our community-engaged approach to workforce training are evident across CMC's region. Our very own Asa Dehan is a research technician with the Aspen Global Change Institute, and our very own Madison, as we know her, Maddie, right, Muxworthy, is the soil moisture, water, and snow program manager with the Yampa Valley Sustainability Council. That's a mouthful, Maddie, wherever you ended up. Both are here in the room with us today and will be among the partners presenting at tonight's poster session at the Boathouse on Yampa Street at 5 o'clock. Not only is the Yampa an outdoor classroom and lab for our faculty and students, but our Leadville campus also sits at the headwaters of the Arkansas, where our ecosystem science students study fen. And I will tell you, I didn't know what a fen was before I started this job. I do know what a fen is now. Study fen and wet meadow restoration, water quality, river health, and other important subjects. The frying pan, the eagle, the blue, the elk, the white, the Williams Fork, the crystal, and others are prominent in our daily lives, flowing by or near our various campuses. And for many of us, rivers are a part of our identity. I drove in from Hayden this morning and just was dreamy. It was wonderful. My husband and I live in the Roaring Fork Valley, for example. That's our identity. And we have CMC alumni who are directly engaged in the stewardship of our natural resources and are passionate about preserving the world around us. And I'm looking forward to hearing from Cody, one of our incredible alumni. You'll have the chance to hear from one of these outstanding alumni in the panel discussion Thursday morning. And I think I just preempted myself, but I'll congratulate Cody Perry for the amazing work he's doing with the Western Slope Conservation Center and certainly on the Dolores River. And the films that he does really are powerful tools to help us all remember these incredible places. So as someone who fell in love with the Colorado River in my home state of Arizona, this is not my home state of Arizona because this was the YRAP a couple of years ago, I'm sometimes baffled and concerned that this iconic river, whose headwaters start here in my adopted home of Colorado, winds its way through the canyons and states, but no longer arrives wet when it reaches the Gulf of California. It has become so taxed and so dammed throughout its journey that it's a wonder it even survives with or without our intervention. And the Yampa is different, and we have an opportunity. It is still a wild river, and we can determine its destiny together, much like the founders of Colorado Mountain College. By coming together and looking beyond ourselves, we too can create a better future for generations to come and for people we may never meet. But the world will be better because of it. So over the next 2 days, you'll have the opportunity to participate in thoughtful and engaging panel discussions on topics like the state of the science and policy, looking ahead to a sustainable water future, building water resilience through connected land-water planning, and creating the confluence, merging the currents of knowledge and action. Love all the puns in there. You will be able to see the research our students have done through the poster session and course, and of course go on the field excursions along the Yampa and the Elk Rivers. And we do have a fairly special surprise. It may not be a surprise anymore, I don't know. But we do have a special guest joining us at lunch. So please don't duck out because that'll be important. So as you participate in YBR 2024, I encourage you to reflect on what each of us can do to prepare for the future. We are all stewards of this special stream that we call the Yampa. It is up to us to pass it along better than we found it for future generations. And I am so proud and so pleased that CMC is part of this important effort. I've been absolutely honored to be part of it, and I hope you'll continue to invite me back. Thank you. I guess I'm supposed to stay up here.
Oh, that's right, I forgot.
Well, yeah. We need to.
Been branded. Okay.
And now for panel one of our event, it is my honor to bring Jackie Brown up. Jackie will be our moderator for panel one. Jackie Brown is Tri-State Generation and Transmission Association's Senior Water and Natural Resources Advisor and a Steamboat Local. She works on legislation and policy on both a federal and four-state level relevant to hydropower. Tri-State is a not-for-profit wholesale electric power provider serving 41 million members in 4 states. She is on her second term and former chair as Governor Polis's appointment to the Colorado Water Conservation Board. She also serves as the Energy Director on the Colorado Water Congress Board and is the current chair of the Yampa River Fund. Jackie was appointed to the Colorado River Drought Task Force to represent industrial water use on the west slope of Colorado in 2023. And before I pass the mic off to Jackie, I'm just going to remind our audience members that this year we are utilizing a platform called Menti. You'll see the QR code in the top corner of that slide and on the in the center of every table in the plastic stands that Garrett is holding up. This is a great way for audience members to fully engage by capturing their thoughts and questions. Platform that then Jackie can see later, and your participation will ensure a really rich Q&A session at the end of the panel. So please, all you have to do is scan the QR code with your phone and take full advantage of this platform for questions.
Thank you, Jenny. I do need to clarify that Tri-State serves 1.4 million members, not, I think you said 41 million, which is a lot. But either way you look at it, but just wanted to clear that up. Thank you for attending this awesome 2-day learning extravaganza. And thank you to CMC, our local partners, and the steering committee. They've put together a really nice presentation for the audience today. So today's first panel is the state of the science and policy looking ahead to a sustainable water future, which is quite the mouthful. There is, as you can imagine, much to discuss under a heading like this. There's no aspect of water management that happens in a vacuum. Population growth, natural disasters, economics, they all play a role. But today's panel is less, why is water management so hard, and more, how are we doing it? So I'll start off with dishwashers. And you'll have to bear with me. Last night, I asked my almost 13-year-old son to load the dishwasher. And to do some dishes, there were knives and wooden items that couldn't be put into the dishwasher. So this morning, I got up, and there's an interesting stack next to the kitchen sink, and I thought, oh, great, well, he did it. I opened up the dishwasher, and he had somehow loaded the dishwasher only using what you could reach into the dishwasher and load. So there's an entire dishwasher full of dishes in just the first, 1/4 on both the top and bottom. And I thought, well, that's interesting. And so this morning, I was going to start with a quote from Mary Oliver, which is, said the river, imagine everything you can imagine, and then keep going. And so I said to him this morning, imagine a machine that can wash the dishes, but you have to pull out the drawers and load the dishwasher correctly in order to do that. Which he said, of course, Mom, I don't want to talk about this. So I am sure everyone in this room has an idea of how to load the dishwasher correctly, and we could probably talk about it for a little while. But the point here is that imagine everything you can and then keep going. And our 3 presenters today have done that in their work, and I'll ask you as well to imagine what we could do and keep going once you get somewhere in that thought, right? So my question after our panelists speak to you all and to our panelists are to imagine what you would do for water management if funding weren't an issue. And you're welcome to reply on this Menti platform if you have some ideas as well. But first, we'll hear from our speakers. We'll begin with Dr. Becky Bollinger. She's the Assistant State Climatologist at CSU's Colorado Climate Center. She will walk us through the trends in Northwest Colorado's climate and how those trends have produced different scenarios that may impact our water management. Then we'll hear from Dr. Deanna Nash, a postdoctoral scholar visiting us today from UC San Diego Center for Western Weather and Water Extremes. Dr. Nash will explain atmospheric rivers and the critical importance these events play in providing our water supply, even as far inland as Northwest Colorado. And then last but not least, we will hear from Kelly Romero-Heaney. Kelly has had an impressive career in natural resources and currently serves as the Deputy Policy Director at the Colorado Division of Natural Resources. She's also a Steamboat local, and I'm guessing happy to be home after a whirlwind 4-month legislative session in Denver. She'll share just a few of the water bills that passed this year and how their impacts will affect Northwest Colorado's water management. Thank you. Becky? Oh, yeah.
Thank you. Thank you so much for allowing me to be here. I've been to the very first one of these Yampa Basin Rendezvous, and I haven't been since, but I always wanted to come back, so I was very excited to get an invite to speak again. I am the Assistant State Climatologist with the Colorado Climate Center, and I'm going to talk to you a little bit about our latest report that we released in January called the Climate Change in Colorado Report. It's the third iteration of it. Last publication was in 2014, and so we were long overdue to add a new report. And the one thing I'm really bummed about is that I had, I'll just put it on there. You can scan the QR code to go to the report or go to climatechange.colostate.edu. So today I had big plans of, a lot of the report has example graphics from the Colorado River, but we have the data from the Yampa River, and so I was going to make all of the graphics for the Yampa River to showcase here. And then when I brought my laptop on my road trip, I realized I couldn't add my Python environment to actually run the code. So I was really sad and that I couldn't do that. But I will show it for the Colorado River and then visit the website, and I'll add them for the Yampa River when I have a chance. Every chapter we have in the Climate Change in Colorado report is laid out with a table at the very beginning to show you what our observed changes are in the indicators and what the projected future changes are for the indicators. And then most importantly, on the right side of the table, we include our confidence in the change. So when we're talking climate change in Colorado, we're very confident in the changes in temperature that are happening. We're confident that we are warming. We're confident that that warming is going to continue into the future. But when we start talking about precipitation, we have been in a recent drier period for since the turn of the century to the 21st, and we don't know what's coming in the future. So our certainty is low. So we've got two maps here showing our observed changes of temperature on the left and precipitation on the right. So when we look on the left side, we're looking at the trend for 1980 to 2022, And you can see we've divided the state up into 11 different climate divisions. And we've kind of split the Northwest into two divisions there, one more over Rio Blanco and Moffat counties, and then the other one more focused over Routt County and North Park. But everywhere you look, you're going to see warming. And the most significant warming we've seen has occurred in the southern part of the state, and particularly around the Four Corners and San Luis Valley. When we go and look at the right, there were a lot of ways we could look at how the precipitation might have changed over time. And in this example, we decided to use the 21st century average so far compared to the 1951 to 2000 precipitation. So everywhere you look, you're going to see a negative number, meaning that in that time period, we have seen drier conditions, less precipitation, and that's most pronounced in the south again. So here's a look at the projected changes in temperature for the entire state. We worked with two climate model projects. The first is the CMIP 5, which is a little older, and then very recently released was the CMIP 6. So they're both just these big climate model intercomparison projects, and the N at the bottom there, N equals 37, N equals 22, is the number of models that we used to come up with this temperature projection for Colorado. And so we compare to a 1971 to 2000 base period. So we take the average temperature, how much have we warmed? Since then, how much are we going to warm? So on the left, I'll focus on that one. That orange bar shows a range of warming from about 2.5 degrees to just over 5 degrees. And you'll see that yellow dashed line is showing how much we've already warmed. And I like this because first, it's a great example to say we are already experiencing climate change. It's not something that's in the future, it's something that's happening now. The other thing I like about it is that it kind of puts us in a place where we say, we're not going to warm an additional, 2.5 to 5 degrees from where we are now. We've already warmed 1.5 degrees of it. So now when we look, okay. I thought I was going on to the next slide. Okay, so I wanted to show how we've broken this down by our different regions. So this one's looking at the Northwest climate division that we have. And what we're looking at is the projected temperature changes from all the models for each month of the year. So we know that we plan to see warming temperatures throughout all the divisions all around. But by 2050, we're looking at these changes happening over the Northwest region. And a couple of things that I like to point out here are that we see kind of a lot of outliers showing extreme warming in the spring, but the most significant warming happening in the summer and fall. And this is a look at the projected changes in temperature, and now you'll know why it's so uncertain what we plan to see. It's not that we plan to see no changes in temperature or precipitation, it's that the models disagree. Are we going to have a wetter future or a drier future? So again, we're looking at the two model projects, CMIP 5 on the left, CMIP 6 on the right, and by 2050, what do we expect the precipitation change to be? If you see the blue bar, those are models that indicate a wetter future by then. And then the brown bars indicate a drier future by then. And so there's a lot of uncertainty about what we're going to see in terms of precipitation. Taking that same Northwest division, you can see how that lays out throughout the months. A couple of things that I like to highlight in this is that we tend to see a little bit of that wetter signal showing up in the winter months, and we tend to see more of the drier signal showing up in the summer. Chapter 3 is a really important one that we talk about basically Colorado's water and how has our water changed and expected to continue to change. And I'm sorry to be the Debbie Downer with this table because it's a pretty wah table. But you'll see we look at snowpack in the spring, runoff timing, stream flow volume, evaporative demand, and summer soil moisture, all showing that with warmer temperatures, we're basically going to have less water available to us throughout the state. So we break down the projected snowpack changes by some of the major watersheds. So the first watershed you see there is the Colorado River near Dot Cerro. And then if you go into the third one from the left, that's the Yampa at Mabel. And again, we're looking at changes in snowpack on April 1st. So that's very close to peak timing. And what do we expect to see by 2050? So where you see the orange bars, we expect to have less snowpack by April 1st, and where we have the greenish bluish bars, we expect to see more snowpack by April 1st. So South Platte on the far right, Arkansas on the far right have more uncertainty with them, but pretty much all of the other basins tend to lean more towards we're going to have less snowpack by 2050. This is one of the ones that I wanted to do for the Yampa River, but sadly I don't have it. So this is for the Colorado River near Dot Cerro, and what we're looking at is how the snowpack accumulates throughout the water year. It peaks in the spring, and it starts melting. We're in the melting phase now. So the black line shows that baseline of 1971 to 2000. What did snowpack typically do? So we start in October, we quickly build up to that peak in the April time period. And then the thick dashed line is the median projection of all the models. And then the thin purple lines are all of the individual models. What are they showing? So you can see that some of the models indicate a higher peak snowpack, and most of them tend to show a lower peak snowpack with melting that occurs earlier. This is important because it also relates to our stream flow changes that we see. So this is looking at the annual stream flow volume and how do we expect that to change by 2050 for each of the basins. So where we have the brown, there would be less stream flow, lower flows, and where we have the greens would be increased flows by 2050. And so this one, you might notice the difference between this one and snowpack is that this one's tilted a little bit more negative than the snowpack for a lot of the basins. And the reason why is this complicated relationship we have between temperature, precipitation, snowpack, and stream flow. So we're taking that point on the Colorado River again, and we're looking at each individual model. And the dot is that stream flow change. The x-axis is the temperature change. So warming all across the board, it's just the magnitude of warming that changes. The y-axis is our precipitation change. So that gray dashed line is no precipitation change by 2050. Below that is a drier future. Above that is a wetter future. The red dots are decreased flows and the blue dots are increased flows. Key takeaway to this is even in a wetter future, all the way up to about a 5% increase in precipitation, we would still see a decline in stream flows based on the warming temperatures that are projected. And the only way we actually get an increase in flows is with those much wetter futures that the climate models are indicating. So we're more likely than not going to have an impact on our stream flows regardless of the change in precipitation. Final one I wanted to show is soil moisture. And this is summer soil moisture on the Colorado River. This is pretty closely in line with almost all the other basins that we see, where the browns indicate a decline in summer soil moisture and the blues are an increase. Summer. This is every month of the year. What am I talking about? So every month of the year, the interesting thing you'll note is that on those March, April, May time periods, you see a huge increase in soil moisture, largely due to the fact that our snowpack is melting earlier. So we're getting that increase in soil moisture earlier, so it makes it look like the soils are wetter in the earlier spring, and then they dry out earlier than they used to. And so pretty much all the other months we're seeing drier soils. That's all I'm going to give you, but I hope that you can go visit the report. There's a whole chapter on hazards as well. So I will go ahead and stop there.
Thank you so much. And in case the instructions for the Menti aren't clear, if you scan with your phone, I think with your photo app, right? Am I the only person that doesn't know how to do this? Yeah, okay, never mind. All right, so Dr. Deanna, or do we want to take questions now before or take them at the end? Let's see. We have questions already. Are you ready? Yeah. Okay. What accounts for the variability between forecasted precipitation changes between Colorado's river basin? Is it elevation?
So, is this on? It just doesn't sound as loud. Okay. What accounts for variability between forecasted precip changes between Colorado's river basins? Elevation. That is a very good question, and I don't think that because there is so much variability in those projections that we don't know exactly what is driving it and which one is right. So that's where our uncertainty comes in. I think some of it, especially our western divisions, are going to be driven by changes that we might see in winter precipitation, particularly atmospheric rivers, which I hope we'll be talking about soon. And changes in southern Colorado, I really think, are being driven by the warming temperatures, making it less favorable for, that increasing aridity idea, making it less favorable for precipitation. But otherwise, it's hard to get at why we might be seeing the different patterns that we're seeing across the state and across the seasons and into the future.
Okay, there's a couple more. The model spread in future precipitation seemed to be larger in CMIP6 compared to CMIP5. Is that true? What caused that increase in model spread?
So CMIP6 tended to have a little bit larger spread in the temperatures as well. I don't know all of the details that go into the CMIP5 and the CMIP6, but we also had it in temperature, and I think that it's due to some of the changing physics that they've added to the update of the model, where they've increased the accuracy on some things, but it's actually increased some of the uncertainty in other ways.
What are the boundaries on the 11 climate zones in Colorado? Are they hydrological?
So what we did was and we've got a paper on it coming out, is we looked at the climate of every single grid point across the state using a kind of 4-kilometer gridded data set of temperature and precipitation. And we took that temperature and precipitation from 1950 to current and looked at the relationships of temperature and precipitation variability across the state, and were able to kind of cluster them together in the areas that had the best relationships to come up with these 11 climate divisions.
Okay, now I'm going to give you the question, and then I'm going to let you take a breather because it's been rapid fire, because there's a question for me, so I'll answer that one while you think about this one. Folks would like to know, what do you make of the recent paper by Horling that caused for increased precipitation? And do you want to answer?
Is that the Colorado River Basin
I believe
one?
it is. Yep.
Yeah, I think the biggest takeaway I take from that, kind of how I was telling you about our temperatures have already changed from our baseline period, is that our precipitation has already changed from our baseline period. And so we currently exist in a much drier pattern and regime than what we saw at the end of the 20th century. And so I think the takeaway is that if you compare to the end of the 20th century, that 1971 to 2000 baseline, it's going to look a lot drier. But we've had a significant portion of that drying already happening, and so I see it as it's very low likelihood to get worse than it is now, and it's more likely to be a little bit wetter now, even if it's drier than what we saw in the 20th century.
Thank you. So there's a question for me that I'll try to answer, but if the person that asked it could give me a little bit more detail, that would be helpful. So the question is, what efforts are being made to get buy-in from families who traditionally have been employed for decades by the coal industry in Hayden and the rest of the Yampa Valley? So I can only speak for Tri-State Generation and Transmission. Our plant is in Craig, so it's called Craig Station. And as far as efforts, our closures will take place of all 3 units by 2028, and that was a legislatively mandated closure by 2030 that we are operating on. So our company and all of the utilities in Northwest Colorado that are regulated by the Public Utilities Commission does what's called an electric resource plan. And so we look out for 3 to 5 years, and we submit that to the PUC. So the short end of the question is that we recognize that there will be a need for dispatchable energy, which is energy that can be running all the time, regardless of if the wind is blowing or the sun is shining, and that it will be very difficult to close the gap between 97% carbon-free emissions and 100%, which is the goal by 2050. So it's possible that we could, our ERP shows that there could be a siting of a combined cycle gas plant in the Craig area, which would have a carbon sequestration element. And so I wanted to give you that one specific example, but we can't ask people to change their minds about the transition. We can just show that we're adapting as an organization, and that we are doing what we can to keep jobs in the Yampa Valley, if that's possible going forward. So if you'd like more clarification on that, I'm absolutely happy to do that, but I don't want to take up too much of the panel's time. Okay, thank you. Okay. See, I'm not even doing a great job moderating. I'm not going to be invited back next year. That's okay. All right, Dr. Deanna, I'm sorry to take up your time. Come on up.
Great. Okay, can you hear me all right? All right. Hi, I'm Deanna. I am a postdoctoral researcher at the Center for Western Weather and Water Extremes at the University of California, San Diego. Today I'm really excited to share with you some weather and forecasting challenges in Colorado, as well as share some of the work that I've been doing quantifying the contribution of inland penetrating atmospheric rivers to precipitation in the upper Yampa subbasin. And I'll also briefly describe some of the relationships that we're seeing with atmospheric rivers and drought here in Colorado. I'd like to thank our partners at the National Weather Service in Grand Junction for their collaboration with this project, as well as joining us here today. A lot of the insight into the forecasting challenges, as well as the specific extreme weather events information came from them. Okay. So here on the left, I have a map showing average annual precipitation in inches per year across Colorado. And this is kind of to demonstrate that there is really large spatial and temporal variability in the precipitation in Colorado. This makes it really challenging for forecasting precipitation. We can look at this map and see that the darker blue colors are indicating that higher precipitation value. And so if we focus on those dark blues, we're seeing that the majority of our precipitation in Colorado is falling and accumulating on the western slope. If we look at the map on the right, this is showing the month of maximum average precipitation across Colorado. So this is telling us when that precipitation is occurring. And so if we focus on Routt County here in Steamboat Springs, and particularly in the areas where the precipitation is, the precipitation is exceeding 50 inches per year, we see that that precipitation is falling in the winter months primarily, so between November and February. Precipitation in Colorado, like I said, has really high spatial and temporal variability, which sometimes means that during intense storms in Colorado, you can have a lot of precipitation at one location and very little precipitation at another location a short distance away. And so to demonstrate this, I have this map showing the 3-day snow water equivalent accumulation, or SWE, which is just telling us how much water is in the snow, for a 3-day storm period in late December 22, early January 23. And these dots are kind of small, but we can kind of look and see that those dark blue dots are SNOTEL stations that had greater than, I can't even see it, 4 inches of SWE for that 3-day period. But then maybe just a short distance away from these darker blues, you have some yellows that are showing very low amounts of SWE accumulation. And so this type of precipitation coming in and having this large spatial variability is largely because of the intense, complex topography in Colorado, as well as the fact that a lot of these storms start over the Pacific Ocean. And as they make their way inland across mountains and other barriers, they're becoming disorganized over space and time. So we have these forecasting challenges here in Colorado, but there are these storms called atmospheric rivers that actually offer a really good proxy for precipitation. And so here I have an example of an atmospheric river that's making landfall or crossing from ocean to land in Southern California on December 31st, 2022. And atmospheric rivers we define as long but narrow bands of intense water vapor transport. So here the shading is showing us that integrated water vapor transport, or how much water vapor is within a column in the atmosphere, multiplied by the wind. And so the darker shadings on this map is indicating that higher water vapor transport, and then the arrows are indicating the direction of that transport. Let's see. So here we have that same atmospheric river, but 12 hours later, and you can see some of that water vapor transport has penetrated inland. A lot of the media attention on atmospheric rivers focuses on when they make landfall on the U.S. West Coast, but this work that I've been doing is fairly new research and is looking at how these atmospheric rivers make their way inland and how they're contributing to precipitation here. And this information can be really useful for short-term precipitation forecasts, as well as some other applications. Something you might notice that when you're looking at these maps is that, you might have noticed, is that the units for the water vapor transport starts at 250 units. And that's kind of an arbitrary threshold that we use typically for identifying atmospheric rivers that are making landfall on the US West Coast. But in Colorado or other inland locations, there's not a lot of water vapor in the atmosphere. It's very dry here. And so what we need to do is we need to lower that threshold to kind of see where that water vapor is making its way inland into Colorado. So here's that same map, same time, but all I've done is added lower water vapor transport values here. And so you can see that that plume of moisture is extending very far inland, and areas of western Colorado are reaching up to 150 units of that water vapor transport. And what we've seen is that, so here's kind of an example of an atmospheric river making its way inland, and when it does, when we have these higher moisture content values, it can result in extreme precipitation. However, if we use traditional methods for tracking atmospheric rivers overhead directly, we find that there's actually less than one atmospheric river per year that's reaching western Colorado. Eastern Colorado, in this example, sees up to 10 atmospheric rivers per year. And so this is kind of the main nexus of our research at this point is how can we objectively identify atmospheric rivers that are making their way inland to Colorado, because we have information from the National Weather Service, our collaborators, saying we know that there are atmospheric rivers making their way inland to Colorado and contributing significantly to precipitation. So what we've done and what I'm going to share with you today is our results of our backwards trajectory analysis, and this is kind of just a different way to identify atmospheric rivers making their way inland to Colorado. So what we did was we took every precipitating day in the upper Yampa subbasin and ran backwards trajectories for 72 hours. And then we said, if we follow that air parcel from the upper Yampa subbasin all the way across the coast, when that parcel crosses the coast, is there an atmospheric river overhead? If yes, we attribute that precipitation in Colorado to an atmospheric river. So I'm going to show you an example of what that trajectory looks like, because that's kind of a lot to envision. Okay, so if we focus for a moment on the image on the left, this is in the blue bars showing us the SWE accumulation for each day for that same storm that we've been looking at the whole time, late December 22, early January 23. And we see that we got over 1 inch of SWE accumulation at the Tower Snowtell Station on January 1st. And then the black line here is that water vapor transport value at that same location. And so we can kind of start to see this relationship of, oh, there's this increase in water vapor transport kind of associated with this increase in SWE. And then the animation on the right is showing the animated integrated water vapor transport values in the shading for that atmospheric river event. And then the little dots are moving forward in time. 1 hour is that air parcel that we tracked for this trajectory for this storm. And so this is moving forwards in time, but the analysis was done backwards in time. And so the black dot, the kind of darker dot, is the air parcel at the time of that current step in the animation. And then the gray dots are the past locations of the air parcel. And so this is really cool because we can see that that air parcel that reaches the upper Yampa subbasin for this storm follows along really nicely with that atmospheric river. It's either within or just above, in front of that atmospheric river for the majority of the storm. And so here is a really messy, what we call spaghetti plot, showing all of the trajectories that we ran for the upper Yampa subbasin that crossed the U.S. West Coast. And so of the 2,000 trajectories that we ran for that 23-year period, we found that 500 were associated with an atmospheric river at the coast. And so that translates to about 20 atmospheric rivers per year reaching the upper Yampa subbasin. And that's a lot higher value than just that directly overhead atmospheric river value that we looked at earlier, which was 1 per year. So, like I said, this math is super messy, but there's something we can do. Each of these trajectories has 27 points along it. We can interpolate those points to a grid and say how many points for all of the trajectories fell within each of these grids. And that gives us an idea of where the air parcels are coming from and the pathways that they're taking. So here's that heat map of those interpolated points from the trajectories to the grid. And so the darker shading is indicating a higher frequency of trajectory points in that grid cell. So you'll see like at the upper Yampa subbasin, it's a very dark value, and that's because all of the trajectories start from the center of the subbasin. And so we're kind of focusing on these like mid-green values here that are showing us the pathways of the moisture transport as it moves inland. So for example, we have a higher number of atmospheric rivers coming in from Oregon and Northern California, as well as up from the Baja Peninsula here. And some future applications for this is that we would like to create a probabilistic forecast tool that says, hey, we have an atmospheric river making landfall in Southern California today of this number of strength. Here's what we can anticipate in 3 days' time for precipitation in the upper Yampa subbasin. And this will be very helpful situational awareness for our National Weather Service partners to kind of get them rolling on sort of weather watches and advisories that they need to be putting out. So then here's some historical statistics for the contribution of precipitation. So this bar chart is looking at annual precipitation in the upper Yampa subbasin. The light blue bars are total, and then the dark blue bars are that contribution from atmospheric rivers. And so there's kind of some variation from year to year, but on average, atmospheric rivers are contributing about 10 to 30% of that water year precipitation, which is actually a fairly high amount of precipitation contribution, particularly this far inland. If we isolate it down to the top decile precipitation or precipitation days where it's greater than the 90th percentile, we get this map. And so again, the light bars are the top decile precipitation for each water year, and then the darker reds are the values that are associated with the atmospheric river. And when we do it this way, we actually show that atmospheric rivers are contributing 25 to 68% of that top decile precipitation. So that means that these atmospheric rivers are higher impact precipitators when they're occurring in the upper Yampa subbasin. Okay, this is a lot of fun. So here I have up on the top, this is not my figure, it's a U.S. drought monitor category. You might be familiar with this. This is for the upper Yampa subbasin. And so the shading in this is telling you what percentage of the upper Yampa subbasin is within each category of drought. And so these lighter colors, like D0, I believe is abnormally dry, versus a D4 is exceptional drought. And so, for example, let's look at this December 31st, 2002. Pretty much 100% of the upper Yampa subbasin was in this D3 to D4 category, so it was in an extreme drought at that time. So this helps us identify times of drought and times of non-intense drought. For example, more intense drought would be that 2020 year where those reds are darker shaded. Now I've added on the bottom the frequency of atmospheric rivers associated with precipitation or atmospheric rivers that are associated with precipitation days in the upper Yampa subbasin. And the time series roughly align. This is a pretty crude analysis, but it's kind of exciting. So we can kind of cross-compare these two and notice some things, particularly that there are times where there is lower frequency of atmospheric rivers that leads up to or is prior to an intense period of drought. So for example, we've got 2002, 2013, and 2021 with all these kind of lower values, a lower frequency of atmospheric rivers. And then on the other hand, we've got some times where there was higher frequency of atmospheric rivers making their way inland to the upper Yampa subbasin that's associated with a lower intensity drought situation. So I've got 2005, 2014, and 2022 here. And so this to me, like I said, this is very preliminary analysis. We're looking forward to doing more with this, but is kind of indicating that atmospheric rivers, particularly those extreme ones, are maybe playing a role as a drought buster in Colorado. And then to kind of end the presentation, I wanted to just briefly discuss what to expect in future years in terms of atmospheric rivers. So Becky did a really great job describing the changes in temperature and precipitation. But this is kind of a summary of what we know for specifically atmospheric rivers in North America. And so the shading on the map is saying where we're anticipating an increase in atmospheric river frequency. I believe that's based on the CMIP-5 model projections. And then overall in North America, I'd like to, I guess, emphasize that increase in snow and ice melt. So particularly due to the increase in temperatures that we're seeing, that we're already observing and will continue to observe, atmospheric rivers, as they come in, if the temperatures are warmer, you're likely to see an increase in the elevation of the freezing level, as well as those increased temperatures are likely to more increase that snow and ice melt. Other things that are possible in this kind of future scenario is an increase in flooding related to atmospheric rivers as well due to an increase in extreme precipitation. That's all I have, but I'd be happy to take any questions.
Great job. Thank you so much, Dr. Deanna. So I either broke the Menti poll or there are no new questions. Either are possible. Let's see. Oh, see, now there are. I was thinking that I had really messed things up before. Okay. So we have time for a couple questions now. The first one is, why are there 10 times more atmospheric rivers in eastern Colorado compared to northwest Colorado? Does this translate to precipitation falling or simply classified by IVT?
Yes, that is a great question. So this map, this is based on a atmospheric river detection algorithm that identifies atmospheric river objects globally using that integrated water vapor transport percentile threshold. So if there's water vapor transport that's above the 85th percentile and it meets the requirements for that like length, width, shape, and direction of the atmospheric river, then it says, yes, this is an atmospheric river. So the atmospheric rivers that we're seeing, that up to 10 per year in eastern Colorado, are actually plumes of moisture that are coming up from the Gulf of Mexico. So that's that. And then we are currently doing quite a bit of analysis on both eastern and western Colorado. And the eastern Colorado analysis is a bit trickier in differentiating that atmospheric river from that monsoon moisture from the Gulf of Mexico.
I don't know why this is so hard, but I'm really having trouble scrolling through the questions, so bear with me for just a second. Or come help me, because I can't do it. This is a once-in-a-lifetime opportunity for me to be here, because I'm never coming back. Okay. Okay, here we go. All right. Are there any lessons we can now take from ancient Native Americans, e.g. Hoboken 1,000 years ago in the Phoenix Basin, that might help us adapt better?
That's a really interesting question for an atmospheric scientist. So thank you for the challenge. In addition to this project and working on atmospheric rivers in Colorado, I do quite a bit of work looking at atmospheric rivers in southeast Alaska. And that work involves a lot of community-led efforts. The tribes are kind of telling us what's important and what they're doing in terms of, and what they know in terms of whether it's more of a me learning experience than them learning. And I know, like, southeast Alaska is a rainforest and Colorado is not, so that's, like, very different in terms of what we could learn there. But I am absolutely certain that there is knowledge that could be gained and shared. That we have. Okay. I think that atmospheric rivers have been happening as long as there's been atmospheric circulation happening. We weren't able to identify them until the early 90s when we had access to satellite imagery that was then able to show us these plumes of moisture. So they are a global phenomenon. They are happening every day. At any given time, there's at least 9 atmospheric rivers across the globe. And they've been happening for a long time. Yeah.
Okay, thank you. We'll do another Q&A at the end of the presentations. Thank you so much, Dr. Nash. And now, Kelly Romero-Heaney to present on policy. Thanks, Kelly.
Good morning, everybody. Thanks for the introduction earlier, Jackie. I can barely see over these. My husband, who's here, can testify that this is what I look like when I drive his pickup. I might just do this here. Am I going to break any rules? Okay, cool. Thank you. Well, again, my name is Kelly Romero-Heaney, and I have recently transitioned into a new role with Colorado's Department of Natural Resources. I'm now the Deputy Policy Director. I was formerly the Assistant Director of Water and Advisor to Governor Polis on water policy. As I have shifted to this new role, I now get to oversee all of DNR's natural resource policy areas, including parks, lands, and wildlife, energy and innovation, water, of course, federal affairs, and forest health. And you're probably wondering, like, how does one person cover all of that? And the short answer is you don't. You have an incredible team of subject matter experts that are leading in this space across the state of Colorado. So I'm super privileged to have the opportunity to take care of my team that's working in all of those areas. But today, I'm here largely to talk to you about some of the laws and policies that came out of the 74th General Assembly. There were, I think, almost 800 bills introduced this session. That's a lot of new laws. Not all of them made it out. But today, I want to talk about some of the laws that did make it out of the legislature, and the bills that relate closely to some of what you just heard, and then also how they apply to water management in the Yampa Basin. So let me start with the laws that the governor has already signed. For Senate Bill 2405, this was a new prohibition on non-functional turf. If you don't know what non-functional turf, just picture grass where you wouldn't put a baby. That would be like a median between a sidewalk and a roadway under trees. So we don't need any of that silly turf, silly grass, if you will, in Colorado because it just takes water. And instead, we need to start transforming our urban landscapes in the Front Range and even here in Steamboat Springs so that we have more drought-tolerant species in those areas, pollinator species, urban tree canopy. So definitely leaning into transforming our urban water use to become more adaptable. Another one, Senate Bill 2437, Green Infrastructure and Water Quality Management. I'm a little nervous talking about this because this was the brainchild of Dr. Evan Thomas, who's in the room. Put your hand up. Everybody needs to talk to Evan about this bill. It's incredible. They'll be doing a study with CSU and the Colorado Department of Public Health and Environment on looking at ways to use green infrastructure to meet water quality regulatory obligations. An example of what that would look like here in the Yampa Basin, imagine you've got a temperature issue on the Yampa, right? We're all pretty well aware of that. The wastewater treatment plant has to meet certain temperature standards. There's too much, the river's too warm. Great way to cool off a river is to shade it with trees, native trees, which is far more climate friendly than building new cooling tower, which has its own carbon footprint. But again, talk to Evan over there if you want more details on that bill, which was signed Friday in the San Luis Valley. So next I want to move on to the bills that are literally, like as I speak, sitting under the governor's pen in Silverthorne. The first one is the Colorado Water Conservation Board's annual project, which Jackie had a key role in as a board member on the CWCB. This bill happens every year. It's how we allocate funding for really important water projects, which of course help us to adapt to drought. $220 million in this bill this year 165 million of that was for loans for water projects that will largely support growth in the urban Front Range, but also East Plains farmers. The interest off of that helps to support CWCB operations and projects. Also includes $23 million in water plan grants. Those water plan grants have supported projects right here in the Yampa Valley, like the Maybell Ditch Project, riparian forest restoration, and a host of other really important projects that help to take those climate impacts, turn them into policies and projects on the ground that help us right here in the valley. Also includes $2 million for turf replacement, so we can get rid of that grass that we wouldn't put a baby on. $2 million in, we say innovative water forecasting, but again, getting nervous, don't want to talk about it too much because this is Jeff Deems's project, the Airborne Snow Observatory. Talk to Jeff if you want to learn more about that program. It's incredible. Also $4 million for drought planning, and then also $20 million for the Colorado River District to acquire the Shoshone water right to help maintain flows on the Colorado. Another bill that the governor is signing right now is a Species Conservation Trust Fund bill, $5 million. Half of that goes to the CWCB board. 1.8 million of that goes to the Upper Colorado River Endangered Fish Recovery Program, which the Yampa is critical to the survival of those endangered fish. Supports projects like acquiring water, leasing water out at Elkhead to restore flows on the Yampa, the Walton Creek, Yampa Confluence Project, things like that. All policies and laws that passed and are being signed now. Now I want to pivot. Oh, sorry, one more I just want to add too that's being signed right now is House Bill 241379. This is the Dredge and Fill program that we really needed here in Colorado due to a Supreme Court decision that came out in March. It was the Sackett decision, which drastically reduced the water bodies that are now covered by the Clean Water Act. And what that means is a lot of water bodies, streams, wetlands, lakes in Colorado could be impacted by development without any sort of regulatory limits. So fortunately, we're able to get that bill passed. The Colorado Department of Public Health and Environment will create a new regulatory program for permitting regulations. The key to this bill is it is so much more cost-effective and technically feasible to protect the healthy water bodies that we have in place and to try to restore and fix the broken ones. Okay, now I'm going to go to the bill that will be signed here. As Dr. Hauser alluded to, the governor will be here at lunch to sign Senate Bill 24197, and this is the Colorado River Drought Task Force. This bill has a particularly close tie to the Yampa Valley. It stemmed from a task force that was created by last year's legislative session. It was the Colorado River Drought Task Force. Jackie and I both served on that. I represented the Department of Natural Resources. We traveled around the state, got together, had tough conversations with water folks, trying to figure out what programs and policies do we need in place so that we can prepare the state of Colorado to adapt to drought, plan for drought, particularly in the Colorado River Basin. There were a number of recommendations that were that emerged from that group and that we voted on, and all of them are moving forward either through the projects bill I just noted, administrative actions, or this bill that will be signed today. And the elements in that bill include things like adding another tool into the toolbox of stream flow restoration in Colorado. So now you will be somebody that owns water in a reservoir can loan water to the CWCB's in-stream flow program. That water, and of course it goes through a pretty robust process, that water can go to support an environmental need on the river. There's a robust analysis that Division of Water Resources does to make sure that other water users aren't injured. But nonetheless, it really does help, particularly basins like the Yampa, provide additional tools so that we can restore flows in the Yampa when we've got those dry, low flow times a year and years. Also, we'll be looking at reducing and waiving the matching requirements for water plan grants for the Southern Ute Indian Tribe and the Ute Mountain Ute Tribe. There are a lot of longstanding barriers for our tribal partners in accessing those funds. So excited to see that move forward. Also, there's an element to the bill that will help to ideally reduce the incentive for agricultural water right owners to sell their water rights permanently to municipalities. Instead, they could temporarily loan them and then keep that water and agricultural production on the years that the municipalities don't need them. And then, of course, finally, there's an element of the bill that provides water rights protection for the utilities in the Yampa Valley, Tri-State, and Excel, so that they can preserve future options for clean energy development in the Yampa, with the hope that in the interim, between the time that the power plants close in 2028 and when they need to use that water again, that water, the Yampa River will benefit from that water being in the stream. So that's a mouthful, a lot of policies, a lot of laws got passed. What are we going to do looking forward? What laws are on the horizons? What policies do we need to focus on? You know, and as we saw from Becky's presentation, the climate, by the time I retired, hopefully am retired in 2050, we'll see, the climate will look a lot, will be different than the climate looked like how the climate was in Colorado when I was born, which is in 1980. So we know that by that time, I mean, climate is going to affect everything we do in the natural resources space. I mean, it even does today. So how can we prepare for that today? The Department of Natural Resources, our executive director's office team, came together last October for a retreat, and we talked about what do we want to focus on. We came up with these 5 strategic priorities. The first one is advancing biodiversity in our state, and that will require reconnecting landscapes, trying to utilize state lands, partnering with federal landowners and private landowners to really advance biodiversity in Colorado. The second one is ensuring a smooth energy transition. I mean, that's not just transitioning to clean energy, but also trying to mitigate the impacts of even clean energy production on our wildlife. Also, a lot of revenue is generated for water projects from oil and gas, from severance tax. How are we going to fill that funding gap? Another strategic priority that we have is enhancing tribal engagement, not just to kind of make up for all of the many, many broken promises that were made to the tribes in Colorado, specifically the Southern Ute Indian tribe and Ute Mountain Ute tribe, but also to learn from their traditional ecological knowledge and apply that to how we adapt to climate change here in Colorado. The fourth is how we're going to balance conservation and recreation. I don't have to tell a group in Steamboat that there's a lot of recreation pressure on our natural and wild landscapes. And then finally, strengthening climate resilience. The Center for Climate and Energy Solutions says that improving climate resilience involves assessing how climate change will create new or alter current climate-related risks and taking steps to better cope with these risks. So all of these priorities are interrelated. All of them are hard, but this last one is the hardest one because, just as Becky demonstrated in her presentation, it's a moving target. We don't exactly know how things are going to change, particularly here in Northwest Colorado. We just know that they will change. And preparing for that will require the exact science that's cultivated by the partnerships represented in this room. So with that, let's move on to questions.
This panelists could come up and join me in this super awkward table configuration where I can't see the slides, but I can see all of you. That would be great. We do have some specific questions here. So once you're all ready, we will do my best to navigate these in the 20 minutes we have. Okay. We'll start with, there's a couple questions about atmospheric rivers that we didn't get to, so we'll go here first. Can you talk a little bit more about how this work could translate to more lead time for Colorado storms?
Yes, so kind of our main hope is that as we learn more about the atmospheric rivers that are able to penetrate inland to Colorado, that backwards trajectory analysis is kind of key there. So I mentioned that we're doing that 72 hours, tracking those air parcels backwards in time, and then saying, here's when they cross the coast. And so our kind of next steps are saying, developing this probabilistic tool that says, okay, here's historically how many atmospheric rivers have crossed these different parts of the U.S. West Coast, and then kind of the lead time, the number of hours that it takes for them to go inland and result in that top decile precipitation. So we haven't done this yet, but this is kind of where we're headed, and I think this will be very helpful and useful, in particular for our National Weather Service forecast partners, because then they can kind of have that situational awareness of, oh yeah, here's a large plume of moisture coming in, and it's very likely to result in extreme precipitation. And then they are able to use their tools, their more high-resolution precipitation information and other meteorological tools to then make decisions and pass messages along to the communities.
Thank you. Kelly, there's a couple questions for you. We'll start with how the implementation of Senate Bill 1379 will be staffed.
That's a great question. So the bill came with a fiscal note that included, I remember it was around $800,000 for staff at the Water Quality Control Division. They'll, obviously need manager of that program, field staff, et cetera. I think as they go through rulemaking, the Water Quality Control Commission will go through rulemaking, better define what that program will look like in future years if they need to come back to the General Assembly and ask for additional funds to staff that up. But I imagine that we could see that in the future.
Thank you. There are quite a few questions, so I just want to note that I think our panelists will be here all day, right? And a happy hour this evening? Okay. So I'm going to try to just pull a few that are pertinent to all of our work. So some of the Colorado River compact questions, I think there's a couple people here that could answer those maybe or touch on them later, but I'm going to skip those for the panel now. Back to you, Dr. Nash. Do inland penetration of ARs contribute to extreme weather in the Midwest, i.e. tornado events and heavier rains in the East Coast?
So tornado events are kind of a whole separate thing, weather phenomenon. From my understanding, atmospheric plumes of moisture are not really contributing to tornadoes. Tornadoes are like very fine scale phenomenon. Atmospheric rivers are much larger. So they're on average 2,000 kilometers in length and 150 kilometers in width, whereas like a tornado is probably less than a couple kilometers. I'm not a tornado expert. But there is some new emerging research looking at atmospheric rivers contributing to extreme precipitation in the Midwest. One of my peers is actually working on putting out a paper currently on some atmospheric river storms in Nashville, Tennessee. And then there's also quite a bit of work going on at our center currently looking at atmospheric rivers reaching the East Coast, specifically impacting New York. So there is some work being done there.
Thank you. We're going to move to the question that I had given you all. If funding were not an issue, what would you do, either in your field or as a method of addressing the wicked problem we have in front of us? We'll start with you.
Okay. So I come at this from two lenses, and the first is I'm a data science geek and I want more data, and so higher density of observations, and not just temperature and precipitation observations, but observations of soil moisture, evaporative losses into the atmosphere, and more information on snowpack. So if it were unlimited, I'd want to put one in every single, 1 meter grid space, but then we would have nowhere to live. So I won't make it that highly dense. I also come at this from a climate services standpoint, in that I am not just wanting to look at data and tell you the problems that you're going to be facing without helping with solutions. And so if I had unlimited funds, I would like to gather with individual communities and help them with developing their own drought management or climate management plans that will make their lives easier as they move through this uncertain future that we have. And if I had unlimited time and funds, I would even go down to the, individual ranch or farmer level and help them. So that's my pie in the sky.
I love it. Thank you. Kelly, would you like to answer that question?
Yeah, I'd love to. I kind of have a long answer, but I'll talk fast. What's really cool about my job is I transitioned from local government. A lot of you probably know I used to work for the city of Steamboat and transitioned into state government. A lot of it, like budgeting, is similar, just more zeros, right? So I get to meddle in budgets with a lot of zeros, but it's still never enough. So if the governor's office and the General Assembly said, here's your blank check, I would invest in our natural infrastructure. That includes our forests. So we've got a lot of really great forest health programs, but also in our riverscapes. And a little teaser for the next panel, Wildfire Ready Watersheds work that CWCB is doing is incredible. We need to be restoring the health of our streams. That also includes beaver restoration, whatnot. So I would invest in that. I would invest in water measurement, soil moisture, airborne snow, telemetry, all the great work Division of Water Resources is doing. And then finally, I would invest in capacity, like not just federal and state bureaucrats like me, but local capacity, because the land and water that we need to manage is in the same places where we don't have many people. So that's where I would use that money.
Ash?
So I definitely agree with Becky that we need more observations, soil observations, more snow-tell stations, snow pillows, because our models and our reanalysis, which is models combined with observations, are only as good as our observations. So an increase in that observation network would be excellent. And then I guess also increased number of researchers looking at this. So when I started in my master's program, someone, and I don't remember who, gave a talk that was like, we have so much data, so much satellite data, so much model data, so much reanalysis data, like tons of petabytes. I don't even know how much. But we need people looking at it and analyzing it to understand these relationships. And so even just from my talk, differentiating how much rain is falling versus snow is falling during these storms. Looking at extreme precipitation events like that result in landslides, floods, and avalanches. Thinking about the drought relationship to atmospheric rivers. Comparing our observations to our models and validating whether or not how accurate they are. This is like so many facets of research. I'm just one person, but more people to be analyzing this data that we already have, plus more data to validate it.
Thank you. And now I need to understand what a petabyte is, but I will do that on my own time.
It's bigger than a gigabyte.
I also have an answer to this question. So on the heels of the Yampa River Awareness Project trip that many of the folks in this room work on, I was thinking that if money were unlimited, I would give everyone a week off and a week's pay and enough money to go be by a river for a week. because maybe by sharing that, people will think more appropriately about their consumption and that direct connection, which I think is really impressive whenever you get people by a river that haven't spent much time by it. So we have a couple more questions. We'll go back to Kelly real quick. Could you speak a little bit about House Bill 241436, the sports betting bill, and the upcoming vote?
Oh, yeah. Yeah, happy to. So this is, stems from the sports betting revenue that goes into the CWCB's Water Plan Grant Program. The voters approved this in 2019 through Prop DD. It's an incredible program. Jackie's involved in making the decisions and how a lot of that money is spent. But it was capped at $29 million. Because we have Tabor here in Colorado, and now that revenue is predicted to exceed $29 million, if we want to keep applying that sports betting revenue for these important water projects, we have to go back to the voters, to the taxpayers, to ask permission to do that. So there was a bill that passed that will then put that measure on the November ballot. And I don't get to take a position on it because it's a ballot initiative,
But that's where the unlimited money is coming from. Okay, and somehow I keep looking at this clock like maybe it's broken, but it's not. So here we go. There's a couple more. Man, people are real. I just also figured out that you can thumbs up questions you like, so thanks for that. All right, I think anyone can answer this. No, we're not going to do that one, sorry. Can you explain the Shoshone water right, Kelly, and that it is not a tribal water right, and what it is? Would you mind?
Yeah, that's actually a really good question because it's called the Shoshone Power Plant water right. Doesn't have to do with tribes at all. It was Excel had a hydropower right. It was a non-consumptive water right over there in Glenwood Canyon. It's been in place for a long time. It is the oldest water right, so it's like what we would call the calling structure, which helps to call water that would otherwise have gone across the divide to the Front Range. There's a lot of agreements that have happened kind of incrementally over time, like the Colorado River Cooperators Agreement, et cetera, to figure out how to kind of work around that. The challenge is the power plant is old, failing, impossible to rebuild. So once that power plant fails, Excel can no longer operate it. That water right would be at risk of abandonment, and that means kind of up for grabs, essentially. So the Colorado River District has been, taking, some of the property tax dollars from its district, including here, seeking money from local governments. They're also seeking money from the federal government, also from the CWCB board, $20 million for a $100 million price tag so that they can acquire that and then take it through water court, turn it into an in-stream flow. Again, there's a lot of sort of nuance there. Happy to talk with anybody about it more, but I know the River District's goal is to try to kind of keep the same flow regime that we see today on the Colorado River with that Shoshone water right call in perpetuity.
Still have time. This is amazing. All right. This one, I feel so important that I get to choose these questions. Now I don't know what to select. All right. So do you want to talk a little bit about the tribal sub-task force on the drought task force? Or we both can, but yeah. Okay. So the question, now I lost it, but I believe it was, sorry, once again, I'll never see you again here. Can't find it. So the sub-task force that was created with the drought task force, the Colorado River Drought Task Force, included members of Colorado's tribes, so Southern Ute and the Ute Mountain Ute. And it also included Becky Mitchell, who's the commissioner for Colorado, and a couple other, I don't remember the makeup of that beyond
The Southwest District was on
Southwest
there,
District,
and then
right.
certainly tribal representatives.
and the tribal representation. So both, so I'll talk a little bit about the process. So when we started at the end of June of 2023, the full task force, including the tribal members, met twice a month until December. And then the sub-task force also met once on their own every month. And so they tackled the specific issues that would assist them in tackling their water issues on the tribal lands, which are tributary to the Colorado River. And one of those solutions that came out of that, I think thanks to Kelly and her work, was some letters from the state of Colorado asking for assistance in match for the Pine River irrigation project, which is a failing irrigation ditch system in southern Colorado on the southern Ute, right? Yep. Yeah. And so that funding will help them be able to use that ditch system again, and they have not been able to use it. So that was a big, I think, win that came out of there. And go ahead and share if you'd like.
Yeah, sure. I mean, the federal government is responsible for taking care of the tribes. Surprise, surprise, hasn't always happened over the decades. And so there's been a real deficit in funding the irrigation improvements that are needed. And so, we're hopeful, continue to advocate. The governor sent a letter, the General Assembly passed. It's a resolution. It's called a memorial, but it's basically a resolution to Congress saying, hey, fund the $35 million budget shortfall that is supposed to support these projects. So I think really, if nothing else, the Tribal Sub-Task Force shed light on these really important water issues that the Southern Ute and Ute Mountain Ute are facing in Southwest Colorado. And there were some other recommendations like waiving the water plan grant, matching requirements, and some other ideas that emerged.
And that last element was included in 197, the bill that the governor will be signing at lunch. And so what that does is it eliminates the matching requirements for tribal projects when they are applying to the CWCB for funding. Okay, that's our time. So, sorry.
I feel like we've all been a part of her nightmare.
Before you guys leave, just a quick look at the schedule. We have a short break scheduled. The bathrooms are outside to your left and then to your right. There's great coffee from Dusky Grouse available for everyone. We should have plenty this year. And just a reminder to be promptly back in your seats at 11 for panel 2. We want to make sure we stay on time because we do have a really special guest and bill signing that's happening at 12 o'clock today, a change to our original schedule. So short break, and then please come back for a prompt start at 11 o'clock.